Hey guys, welcome back. Today we are going to solve four problems: evaluation of risky proposals, alpha adjusted returns, and then zero coupon bond one problem, and then mutual funds. Okay, so four problems we are going to cover in this video. Let's quickly start solving the problem. Okay, evaluation of risky proposals. Harrow Limited is evaluating two mutually exclusive projects. Okay, A and B, they are actually evaluating what they are investing in A is also they are planning to invest to 25 lakhs both in A A and B. The pessimistic, if the market scenario is pessimistic, no, then they'll be earning the expected return of they'll be earning the return of 7 lakh. That probability is 0.2. Most likely 9.5 lakhs, most likely 9.5 lakhs, and probability is 0.5. Optimistic 12 lakh, 0.3. Okay, they have given the standard deviation because the risk involved to earn this project, to earn out of this project. Okay, they have given everything here. They expected expected to generate annual cash flows 7 lakh, 9 lakh 50,000, and then 12 lakh. Okay, so whatever we have just accumulated in a table like format. So what with this information, what we have to do is step 1, calculate CV of A and B. Then step 2, calculate CV of industry, and then we are going to just compare and find which project is best. Okay, what does it mean by CV? To earn 1 rupee of return, how much risk I am incurring? The lower the risk, the best the project is. Okay, so now we got the x values, which is we'll take this as x because x is more familiar, so this is y. Okay, now pessimistic, most likely, optimistic. What's the probability? Probability 0.2, 0.5, 0.3, and then they have given pessimistic value of 7 lakh, 9.5 lakh, and then 12 lakh. Okay, this is the x factor returns on a yearly basis. We have to find out the expected return. Okay, so 0.2 into 7, which is 1.4 lakh, 0.5 into 9.5, which is 4.75, 0.3 into 12, which is 3.6, 1.4 plus 4.75 plus 3.6, which is 9.75 lakhs is the expected return. Then comes x minus x bar. X bar is 9.5 lakhs. X is this. 7 minus 9.75, which is 2.75 minus 2.75. Then 9.5 minus 9.75, which is minus 0.25. 12 minus 9.75, which is 2.25. Okay, yes, p into x minus x bar the whole square, multiply this 2.75 into 2.75 into p factor 0.2, which is 0.55, 0.25 into 0.2, 0.25 into 0.25 into 0.5, which is 0.031, then 0.3 into 2.25, sorry, 2.25 0.3, which is 1.52, 0.55 plus 0.031 plus 1.52, which is 2.101. okay, we got the variance. Square this up, we'll get the standard deviation, which is 1.5. okay, but the thing is, we should not do like this, because we have been given with the standard deviation already in the question itself. So the things which are not required, like how we are doing in portfolio management, we should not do here. okay, now standard deviation given, how much? 1.8 lakh. So what's the CV? Risk upon return 1.8, 9.75, 1.8 divided by 9.75, which is 0.18. now we'll calculate the coefficient of variation for y. now same like P Y P Y. P is 0.3, 0.4, 0.3. Y is 5 lakh, 10 lakh, 14 lakh. 0.3 into 5, which is 1.5. 0.4 into 10, which is 4. 0.3 into 14, which is 4.2. Total is 1.5 plus 4 plus 4.2, which is 9.7. This is the expected return of y. So what's the standard deviation of y? 2.5 lakhs. So CV is sigma divisible by bar x is equal to 2.5 divisible by 9.7. 2.5 divisible by 9.7, which is 0.26 is the CV. So we have calculated the CV for both the proposals. Now we have to find the CV for the industry CV. We have to find out now. okay, CV is equal to sigma divisible by bar x. okay, 8 divisible by 1.6, which is 1.6 divisible by 8, which is 0.2. 10 divisible 2.2 divisible by 10, which is 0.22. 1.8 divisible by 9, which is 0.2. Total is 0.2 plus 0.22 plus 0.2 divisible by 3, which is 0.2067 is the industry CV. So compare this. Lowest is the best. Below the industry coefficient of variation is project A only. So project A is the best project. That this is how we have to determine. okay, we'll go to the next problem. Next problem I have already worked out. I'll just teach you how to we'll have to do this problem. There are two mutual funds, AB mutual fund and YZ, each having the close unit. This is required. okay, NAV as on 31st 3rd 2024 of equity schemes is 81.63, consisting of 98% and remaining balance cash balance. okay, so NAV, out of NAV 98% is in equity and at 2% is in cash balance. YZ mutual fund is 68.42, 95% equity, balance in cash. So all this I have populated here. In the next month, market is going to fall, and they have given the data also to find out the beta. So for beta only this much information has been given. With beta we know now, we can easily solve this problem. So what's the purpose of SHARPE ratio? SHARPE ratio is expected portfolio expected return of portfolio minus risk-free return. So we don't have this we don't have this value. So So we have to find this value using Sharpe ratio. So Sharpe ratio information has been given and variance information has been given. Using this, we are going to find out the RPA minus RF, which is return of portfolio minus return of risk-free risk return of portfolio minus risk-free return. Okay, so once we got the value, we have to substitute this into the trainer ratio. Trainer ratio is return of portfolio minus return of risk-free return divisible by beta. So using this, we are finding the beta here. So our goal is satisfied. We have found the beta, and then opening NAV. What's the opening NAV on the day of 1/4? Which is they have said that 81.63 is the total NAV, and in that they are holding 1.63 in cash and 80 is in equity. Okay, so what's the monthly cost they are incurring? 3% in a year. Okay, divisible by 12, and divisible by 12 into the coming the found percentage should be multiplied into this. You will get this value. Okay, so how to calculate this is 3 divisible by 2, which is 0.25 into 0.25 percentage. You'll get this value. Like that also we have to do this. Okay, this amount will be deducted with the cash balance. Okay, and then once we have found the beta we have to substitute. We have the beta. Using the beta, we are going to drop our share value. Okay, 10% drop is there in the market in the next period. No, so what will be the drop in the shares? So beta, so double the time it will fall. YZ is having 1.4 beta, so it will fall by 1.4 percentage. So that we have to find. So 10% into 10% into 2, 20% fall will be there in equity. So 80 into 20%, which is 16, and 1.4%, 14% is the fall in mutual fund, second mutual fund, which is this 65 into 14%. This is 9.1. At that will be getting 555.9, and this is our closing NAV. Okay, then that is it. The problem is over. Very simple problem. If he comes now, we can easily score 7 marks. There comes the next problem. Next problem is also simple problem only. Portfolio management. What's the expected return of expected return under CAPM formula is what? Risk free minus beta into RM minus RF. RF is what? RF is 5.5. Beta is 1.8 for first portfolio, moon, and then sun. 5.5 minus 1.4 into RM is 11%, which is this. Okay, and then RF is 5.5. 11% minus 5.5. Okay, 1.8 into 5.5, which is 9.9. 5.5, which is okay. This is plus 1.8 into 5.5 plus 5.5, which is 15.4%. Okay, 5.5 plus 1.4 into 5.5 plus 5.5, which is 13.2 is the expected return for sun. So now alpha adjusted returns is, now we have calculated the expected returns. Once we found the actual returns, now we can calculate the alpha returns. How to calculate the alpha actual returns? Actual returns is nothing but the total all this. These are the past 4 years actual data. No, so we have to total this and total this and average it. 14.2 plus 14.7 plus 13.7 plus 15.2, which is divisible by 4. 14.45%. 15.45 plus 12.48 plus 14.7 plus 14 divisible by 4, which is 14.1575. so this is the 156. This is the actual returns. %14.45%, 14.161%. So we have to find out the positive. We have to find out the alpha. Alpha is expected return minus actual return. Okay, we have found this here. We'll keep it here. Okay, expected return. This is 15.4%, 13.2%. What's the alpha adjusted return? 14.45% minus 15.4, which is minus 0.95. Okay, 14.161 minus 13.2, 0.961. So which is, where is the positive alpha is the go to the where is positive alpha is the best investment, best return giving investment for investor. So investor has to choose this. So we'll go to the next problem. Yes, what they have given in the question: issues a zero coupon bond for 10 years maturity. Issue price is 260, maturity value is 1000. So we have to calculate the YTM. So what's the target PV factor? How to calculate the PV factor? The maturity value, issue price divisible by maturity value. So 260 divisible by 1000, which is 0.26 is the target PVF. Okay, into 1000 we'll be getting the 260. Okay, now we'll use two rates like 14%, 15% at 10 years. Whether it falls on this or between this, like that we'll check. 1 divisible by 1 divisible by 1.14, 1 2 3 4 5 6 7 8 9 10. Okay, 0.2697 it is coming. We'll keep it 0.270. Okay, 1 divisible by 1.15, 1 2 3 4 5 6 7 8 9 10, which is 0.247. What's the NPV? NPV is, calculate the 10th year value with the discounting factor. We'll be getting the NPV. NPV is 270, 247. Okay, at 15%. So two rates, 14%, NPV is 270, 15%, NPV is 247. In between it is coming, which is 260. So what's the difference? 270 minus 247, which is 23. 270 minus 260, which is 10. Okay, so 10 divisible by 23, which is 14%, plus 10 divisible by 23, we'll get 14.43%. This is the NPV. This is the YTM for 260 for the bond we have found out. Okay, that is it. We'll solve another 4 problems tomorrow. Thank you.